So I can also write my system of equations in a matrix form like this. So I can take the coefficients from my equations and write them out as a matrix. I would actually normally use kind of square brackets for the edge of a matrix, so I'll just use that. And then I can have my vector of unknowns, and that is equal to my vector of constants, like this. And so this here is a matrix system of equations. The left-hand side, if you multiply it out using the rules of matrix arithmetic, then you will get the system of equations that's written above. But I can actually now represent this as kind of a matrix object. So the matrix of coefficients, I might call that A. My vector of unknown values, I might call that X. And that is equal to some vector B. And so that's the vector of my coefficients. So in particular, what I can do here is kind of solve for X, and kind of formally, mathematically speaking, that is inverse of A multiplied by my vector B. So this is now just an algebraic procedure that I can follow in order to calculate this using a computer program that can do this matrix inverse. As an example of setting this out, I can use something like MATLAB. So I can define my variable or my matrix A to be just these coefficients. So I'm just going to basically type these in from reading off the screen here. So that's, just bear with me, -2, -15, and 15. So if I kind of express my matrix A, then you can see the matrix of coefficients here. I can do the same for my my vector B. So that's 36, 120, and 0. So I'll organize it as a column vector, basically the same as I've written it here. And then I can calculate, basically, it's kind of like written as A divide B, but it means take the inverse of A and multiply it by B, like solve that system of equations. And so those are my answers, right? 15, 8, and 10 are the answers for V1, V2, and V3 respectively. So you can use a computer program to actually help you with these simultaneous equations as well, if you have access to that at the time at which you're solving it.